For this module, we'll discuss at a high level what the product development lifecycle is and the technical jobs involved. I'll also share three compelling reasons why you should consider pursuing a job in the technology industry. The product development lifecycle, or PDLC, at a tech company is the step by step process of how they create a product or an app or website, or maybe even software or even just new features from idea to launch and beyond. In this course, I'll use words like website, software, product, application, all interchangeably because, for the purposes for our goal of talking through the PDLC and the roles involved, there's no material difference between these types of digital offerings. The term PDLC is also sometimes just known as the Product Lifecycle PLC or PLM, Product Lifecycle Management, and there's really not a big distinction among those high level terms either for the purposes of our course. Suffice to say that although there are a lot of stages involved from the idea of a new software or feature, there isn't an exact recipe of steps that every company follows. But generally, you have a few stages up front where higher ups at a company or those that have external facing roles where they interact directly with customers and users, they're planning what projects will take place, whether that's building something entirely new or making updates to something that exists. They use a lot of data and compare lots of pros and cons and use lots of financial models when picking between which projects to invest company time and resources in. These planning steps themselves are a big endeavor, and that pro and con comparisons takes a lot of time and equations and analysis. But once they've done that analysis, there will be some kind of priority order into getting the work that's been decided upon done. Then, these projects that have been decided to go forward are then worked on by the people at the company who do the bulk of the hands on work of designing, making, managing, documenting the software. These roles, represented in that blue color, create the tangible artifacts that the company produces that end consumers typically interact with. Peppered in between these blue phases of day to day working on the project are ideally validation efforts, which seek to validate that the software or feature updates are solving real and worthy problems for people and that the projects that people are working on are likely to result in some kind of revenue for the company or some kind of cost savings. These validation efforts typically include one on one conversations with users and other groups, but there's lots of other methods that might be used too. We'll cover a bit more when we talk about UX research in a later module. The results of these validation efforts may very well, in fact, will very likely result in changes to the design or project, either to be implemented right away or at a later time via the backlog. But anytime you ask for feedback, you're going to end up with some really good points that you hadn't considered. So you'll always walk away with possible improvements to be made. So that's why I said earlier that ideally these validation stages are happening before and during the areas of primary hands on work. Once those endeavors of building and designing and documenting the software are done, other people at the company must then get the word out about the new features or the new offerings, not just by advertising and marketing the updates, but also by salespeople pursuing potential buyers of the software and or these upgrades. They might give demos, they may answer questions, they may talk about the logistics with potential customers. Then, once people are actually using the results of all this work that's been done in these blue sections, people at the company support existing customers or update frequently asked questions. And the people who do the work in both the purple and these gold sections down at the bottom really have a ton of extremely valuable information to then pass back up to the start of this process. So, when higher ups are determining what projects people at the company should work on, sales people and marketers, for example, are armed with the reactions from the market and the reasons why maybe a potential client decided not to go forward with making a purchase with the company, or where existing customers keep having confusion or making errors. So, although on this slide these stages are represented linearly, really these stages are better depicted as a cyclical process with lots of feedback loops. We'll get to have a look at some of these industry standard diagrams for the PDLC processes later in another module as well. The stages that we just looked at correspond to typical job roles that are mainly responsible for those stages to varying degrees. Maybe some of these job roles seem familiar to you, and maybe others are new terms to you. We'll be covering all of these jobs in more detail as the course goes on, so don't worry if you aren't sure of what any of these roles entail for now. When we think about these various job roles and the stages of work, most often they exist within the context of an agile framework. The term agile framework is a broad term that encompasses several different specific methodologies that companies use to get all those stages of work done. And again, we'll discuss this a bit more in a later module. I mentioned a few slides ago various stages involved in the PDLC, and those stages essentially are reiterated or overlap with the stages depicted in this slide. These two models both reference the PDLC and describe it more or less. But the key difference between these two primary concepts on this screen is that with waterfall, which is shown on the left, there are basically no feedback loops between teams. So the teams of higher ups who plan the project, decide timelines, decide goals, decide functionality, pass all of those goals along down to the people who then design out solutions that meet those criteria, and then the designers hand off a completed batch of work to the coders who then start developing the product. But think about this. As you probably can relate from your own personal experience, any big project has elements that are unpredictable, and software development is no different. It could be that in the design and research phase, we discover that people actually want XYZ functionality, but the people at the top of the chain had already decided and planned on ABC functionality. But in Waterfall, there's no step in that process where that learning could be communicated up and accounted for. Or perhaps the developers start working on the software and realize, hey, this set of features you asked for is actually really complicated and it's going to take 3 times as long to do than you had planned for. There really isn't a good way to mitigate that issue in this flow. So, testing could reveal some major issues with the way it was developed, but again, there's no circling back. The term waterfall in this model refers to how decisions and work only flows down and never really comes back up either in a large cycle or in tiny iterative cycles. Whereas with Agile, which is really the standard of any sort of modern method and what you will undoubtedly probably use in a job these days, we as an industry have learned that it saves time and money in the long run to make smaller decisions and anticipate that decisions might change, directions might pivot, new ideas may emerge after a project starts. And those new learnings and insights should be considered and they may change the scope of work. More importantly, Agile fosters collaboration between teams. So the developers are able to tell designers directly and product owners that, hey, the thing you asked for is going to take 4 months, but we can get you 80% of that functionality in 1 month if we decide we can live with some trade offs. Or people talking to users up front, researchers may be able to take those insights of those interviews back to various project heads to then inform and change the goals and milestones of the project from the very beginning. To foster that kind of intermittent collaboration and feedback, projects need to take on more bite sized pieces of work to then be able to say, should we stop? Should we keep going? Are we still heading towards our goal? This requires a really thorough understanding of the end goals for the business of the project. What are we hoping to achieve by taking on this work? Or by building this new app or feature, are we hoping to increase savings, increase revenue generation, increase our customer base? So that you can know how to break the project into smaller tasks that each in their own right should, in theory, contribute toward that larger goal somehow. The other benefit of Agile is that it allows you to deliver something known as a minimum viable product. Imagine you have a really cool idea for a complex new app. Instead of making a really complicated version with all the features right away, you just make a basic version that just does maybe one or two of the most important things that contribute toward that larger goal, say increasing premium subscriptions. Then you get feedback internally and from users externally to make sure that you're on the right track and that what you've produced is usable, intelligible, delightful. If you get confirmation that the upcoming next parts of the plan are still wanted, you can always just add them and keep working. But you can't undo a bunch of work that you already did that was maybe flawed or misguided. So this image is another representation of the previous slide where you're iteratively working on, and most importantly, you're releasing smaller increments to real people to increase your confidence that the investment you're putting into the project overall is worthwhile. Because, say, in this top portion of the image where they just build a car, let's say that they just build a standard car and it's not good enough to differentiate among the market competition. And so it just doesn't sell enough units to be worth the investment that was made into making it. But let's say that through these continuous feedback loops and smaller tasks, the team discovers that maybe a convertible would disrupt the market enough to increase the likelihood of meeting that goal of selling enough cars to cover and then surpass the cost of that investment to have it built. So the concept of releasing an MVP or even releasing smaller increments of your product really doesn't work with waterfall. Over the past couple of slides, we've been inadvertently talking about one of the most critical steps of building good software products or websites, which is requirements gathering. Requirements gathering is a technical, industry specific term that refers to conducting all the research, whether from potential customers or existing customers and users, researching the competition, researching any cultural or historical context, as well as taking into account the goals for the company and any other information that informs the success criteria for a project. Essentially, making sure that the software we're building meets the needs of the users while also having a positive outcome for the company. Once the team has completed requirements gathering, they'll end up with a list of requirements, which are like a checklist of everything the software needs to be able to do so that the project turns out successfully. So, thinking again about waterfall versus agile when it comes to requirements gathering, the bigger of a checklist you try to make for a project, essentially the earlier on in the project, the less reliable and accurate that checklist is going to end up being, meaning the less reliable and accurate the waterfall method is. It's impossible to gather all the requirements at the beginning of a project. Something will be missed by the time it gets to development or testing, or there may have been a flaw in an assumption made early on. So, this requirements gathering piece really benefits from the agile method of breaking the project down into smaller sizes and just gathering those information for smaller checklists at a time. So with Agile, you're just determining the requirements of the skateboard, then the scooter, then the bicycle. These iterative enhancements that will get you to the end result of a car potentially, but in a way that's more confident and less risky than the waterfall method. I've touched on a few of these concepts already. There's a wealth of dozens and dozens of methods by which to conduct research, to gather requirements, or to determine what the software app needs to be able to do. In the middle, there's a term stakeholder interviews. A stakeholder is anyone who has an interest in the project. So, unfortunately, it's a pretty vague term. A stakeholder is someone who would be affected by the project's success or failure. Stakeholders typically refer to other colleagues at work at the same company. So, this could mean interviewing someone from a different department, maybe that tried a similar project to yours in the past, and asking them what they learned and what worked and didn't work. Stakeholders can also technically include people who work outside the company, like customers or even regulatory agencies or other third parties. The term stakeholder comes from the idea that someone might have a stake in something, like a literal wooden stake that used to be placed in the ground to mark territory or a boundary, but now it just means someone that has a personal investment or interest in something. The last step when it comes to requirements gathering is something called prioritization of the requirements. Your checklist for all the stuff you want your software to do will always be too big to fully complete. Every software you've ever used has something called a backlog of work, which is all the stuff they would love to get to eventually if and when time allows. And the way that this backlog of work is prioritized is basically a calculation of what is the value that we are getting, either anticipating new customers, being able to release the software more cheaply, by how long that work is going to take and how many people are going to be needed to do it. So each team and each company is going to have their own calculations and goals here for how they want to prioritize enhancements, but that's generally the last step of that agile planning phase before the work begins. Companies use what is essentially a simple formula, but that has many nuances for each industry or circumstance for this prioritization that I just talked about. They often use something called a 2 by 2 matrix to basically chart each idea or enhancement and determine the value that each of those ideas will have, factored by the effort that it will take to make those enhancements. This formula can help them make that decision of whether or not to proceed with that idea. So, if you have an idea to, let's say, redo the search function for your website, just as a quick example, through all these methods of research mentioned earlier, you should have an idea of how much value you're going to get for redoing the search. For example, decreased support calls, which can translate to a dollar amount based on how much your company pays its support people. And by researching with your technical stakeholders, you would have an idea of if redoing search is a large task that's going to take up all the teams for 6 months, or it's something small that can be done by a couple people in a few weeks. Depending on where that item of redoing the search function falls on both the X and Y axis of this or a similar chart, you would have a quick idea of whether that idea is worth pursuing. And so, all of those ideas that the people at the company have for enhancements, new apps, new products, whatever, they can be evaluated by their value and effort. Before we move on to talking about why you should consider working in a technical job role, I'll cover a few more generic concepts to be familiar with for the course. A concept to be aware of when working in the field of technology is whether your company makes a product that is consumed only or primarily by other businesses, making it B2B, or whether the product your company makes is generally consumed and accessible to the general public, B2C. B2B software is something that you as an individual person generally wouldn't or maybe even couldn't purchase. Think of big companies like Kimberly Clark or Benny Keith or Oracle. But B2C software are the ones where you have the most experience with, not just from a decision standpoint yourself, like deciding to purchase or use or download something, but even using, because most of our interactions with technology aren't specific to work or school tasks. So they're for personal use, thus B2C, or they can be both, either for school and work and for personal use, which still makes them B2C. These types of companies will offer different challenges to those working on their software. For example, B2B challenges often involve really complex workflows, complex scenarios, more technical constraints. These tend to be bigger, messier applications. B2C challenges may sometimes have to do more with keeping up with latest visual trends, aesthetics, technology trends, and B2C applications, because that could mean really anything. They might range in size and be perhaps smaller or larger than B2B applications. Next, we'll look at what it might mean to work at a startup company versus a large established enterprise company. And really, a company will fall somewhere on a spectrum between these two ends. And even B2B and B2C, there are companies that live in both worlds. Those are just the two ends of that spectrum. But a startup is a newer company that is just getting its primary offering off the ground, usually founded by a small group of initial people that perform a wide range of job duties themselves. And then as the company grows, more and more specialized individuals may be hired to perform more niche tasks. You'll find that people working at startups may be, quote unquote, wearing many hats, which just means performing many job functions simultaneously, like coding and designing, or performing legal and HR responsibilities. Secondly, startups tend to not have the rigor or maturity that a large scale enterprise or older company will have. And this is largely due to the fact that they just don't have some of those positions and personnel established to create and enforce certain policies. Thirdly, there will be a difference in the type of benefit package and overall, quote unquote, total compensation, which refers to your salary plus all the extra monetary or capital benefits you would get as an employee. Now, in this day and age, you're probably going to be offered at least medical and dental at any company, startup or enterprise, even if you're working. Now, in this day and age, you're probably going to be offered medical and dental and even 401k benefits working at either a startup or an enterprise. You may even be offered what are called stock options, which is the ability to buy company stock at a likely lower than what it would be traded at on the stock market. Or a startup may offer you something called phantom shares, which are like hypothetical shares if the company were to ever go public and be publicly traded on the stock market or become acquired by a public company. Now, one of the bigger drawbacks of working at a startup is that you would likely be working more than 40 hours a week, but that comes with the benefit of moving up in the company potentially earlier and more quickly than an enterprise, because you're gaining visibility to the higher ups because there's just fewer people. And you would also have a really strong influence on the way things are done. The culture at a startup can sometimes be more laid back, like, stereotypical ping pong tables, but this is not always the case. And a larger corporation or an enterprise corporation can still have a great culture, and that may include some of those social options and general good vibes as well. But you're also probably going to have a more expected schedule of 40 hours per week at an enterprise, but maybe less flexible time frame of working, like you maybe can't work 2-hour batches from 8 a.m. to midnight at an enterprise. Since COVID, return to office policies and work from home policies and flexible working schedules have kind of changed probably forever. And many enterprise companies still offer some kind of hybrid approach to going into the office. So really, this entire graphic kind of just meant to give you a general idea of what you can expect, but each company is going to vary so much. So just be aware that you could get a job at an enterprise company that doesn't fit all of these standards laid out on the table. And one last thing to note here on this fourth line, just because a company has maybe more bureaucracy and perhaps more of a traditional corporate setting, actually doesn't mean that people are less happy working there. Because with that maturity and that bureaucracy will often come more clear roles and responsibilities, clearer success criteria, more accountability measures, but you can't maybe work from Hawaii whenever you want potentially. So it just sort of depends on what role you have and what you personally are comfortable with and what would make you happy and thrive. There's no objective winner when it comes to startup life versus enterprise life. We've talked about how requirements are gathered for projects and types of companies from startups to enterprise, B2B to B2C. But I also have three reasons for you to consider if you're kind of on the fence about what you to do for your career, or if you aren't sure if a career working in the tech field is even right for you. So, to start off, you can work in virtually any industry because every industry these days uses digital technology to some degree. So, let's just say there's something you're really passionate about, like environmentalism or education or TV and film. You could work in a behind the scenes way on the very technology that supports or even is critical to those fields. So, not only would you be interested in the subject matter that you would be designing for, or coding for, or project managing for, or writing documentation for, but you will have an opportunity to interview these types of professionals in that industry as well, like as users or stakeholders, or maybe even attend industry events like conferences. And further to this point, you don't actually need to work at Apple or Google to work on cutting edge technology. Companies that you may never expect, like KFC or Best Western, have internal innovation labs or something along those lines, where they're just investing in new and upcoming technology because you never know what the next chat GPT is going to be. KFC innovations include their K Pro brand, which uses facial and voice recognition to enable customers to pay with a smile or by their voice, and beta versions of their AI that shows you different menus tailored to your tastes. And they also partnered with a video game company to do in store character promotions and collaborations where it could kind of generate a limited edition flashcard of a game character in store, like a Pokemon Go style of augmented reality. Right now, AI and ML is very hot and a lot of people are using it. Lots of companies are adopting open source software to incorporate AI and ML. But Best Western was doing it before this more recent craze where had robotics that were allowing guests to use like a robo concierge to deliver things or adjust things in their room. And it involved interactions experience with an AI, mapping a blueprint of the hotel, etc. So, virtually every industry has companies that are investing in technology and trying to find innovative solutions. So, there really is a wide net of possible types of companies to work for while still having a job in the software and technology industry. For our second point, if you decide to work in technology, you can know that you have a transferable set of skills and that the demand for these skill sets is not going away. We continue to see a rise in the development and investment of experimental technologies with no sign of slowing down. So, this chart itself is a couple years old, so expect to see this trend continue with maybe more fidelity and branching into new technologies not listed here. And you may have heard about some tech layoffs that happened in the 2022 to 2024 timeframe, and it's starting to wane a little bit. And it's true that there were more layoffs than the average year. However, lots of factors also play into that, and it's considered by many to be a course correction due to perhaps some initially overzealous budgeting several years before that, plus economic downturns that happened due to the pandemic that we recovered from. So, just like with any industry, the jobs outlook is susceptible to circumstances within the world at large. But just rest assured that generally, a career in tech and software is still extremely viable and sustainable. Not only are jobs growing in the tech sector, both in number and in career ladder potential, as you start to see specializations with their own executive titles like Chief AI Officer at a company, um, but you see the pay reflect in demand as well, and wages continue to be competitive in this arena. But then there is what I consider to be the top reason for working in technology, and my favorite reason, which is the ability to make a real difference in many, many people's lives. When we think about our interactions with technology, it's a spectrum of positive and negative experiences, or maybe a spectrum of success or failure in being able to use or rely on that software to complete some kind of task in the real world, like navigate a map or drive a car. A lot of the times on that spectrum, we encounter minor inconveniences that are annoying or maybe stall us a bit, but didn't completely ruin our day. However, and I realize that these are two examples of printed design and not digital software, but the message still stands. When products are created for people, for humans, and those products don't ensure that they are easy to use by humans, we can start to get into some tangible implications of the fact that this product or piece of technology was not created with humans in mind, or at least not enough, and that these designs could have used more external feedback and iteration. When you look at, for example, the parking signs on the left, which we're all used to that by now, but how many people have probably either gotten a ticket, gotten towed, simply because they tried to interpret these signs and they just weren't laid out well enough to be intelligible to someone? What if they had done some sketches of these designs and tested them with people on paper and made some agile improvements and feedback loops before they printed them on a bunch of expensive metal? And we're basically stuck with this investment of how they look now. And then, of course, you have instances of where design and technology really fails people in more disastrous ways. A few years ago, 1.4 million people in Hawaii all received this government issued alert on their phones. It's really, really horrifying to receive this message. Just imagine how you would feel if this popped up on your phone. And the mistake wasn't cleared up for 38 minutes. So, to the absolute fear and panic that people had, it caused some PTSD and other negative effects for people. And you may be asking, well, how is this a failure of technology or specifically of design? This is the screen where an employee accidentally hit the wrong link, which caused the false alarm to be sent out. There are probably 20 different ways that this technology could have not failed its user because the design could have been clear and the downstream people would not have been affected. For example, like everything is in all caps or there's lots of really weird capitalization, which is like a design school 101 thing because that's harder for people to read. There's no categorization. We learned in the last unit about proximity. I mean, imagine if this thing had better proximity to things that are test alerts and things that are real alerts and things that are emergencies or things that are just FYIs. People may still be wondering, well, the person who made the faulty click is to blame. And I would disagree with that actually, because people are human and people make mistakes, and technology should at least do its part to help prevent errors that all humans are prone to make. People have sleepless nights, they get sick, they have breakups, they are new on the job, they return to work after having a baby. All kinds of things happen in the real world, and technology is always kind of competing with those other distractions. So when we see an interface like this one, there really is only one group to blame, that is the people who designed this, and then the product managers or the other higher ups who didn't prioritize making very simple improvements to make it less easy to make such a critical failure. And here's a more recent example of a time when technology failed the users in a time of crisis, creating unnecessary emotional stress when there was already enough to be stressed out about. I'm going to jump out to a video clip and then jump back into the presentation to wrap up.
Okay, so we had these big fires in Los Angeles. They were big. It was a scary time. Big fires, like huge ones, two big ones and a lot of little ones popping up. It was a traumatic time, and everybody got this app. I think it's called Watch Duty, and it was this app where you could see fires popping up in real time. So everybody in the Los Angeles area was refreshing the app every 3 minutes, and you just see these little fires. None of them were controllable. It was crazy, and I didn't really understand the app. There was a lot of colors, a lot of different shades of colors. There was like a red that was fire, a red that was almost fire, a red that it meant it's thinking about fire, and then there was other colors. One meant like, you got to leave. The other meant you think about leaving, and then there was the rest that like just be ready to go. So I did not understand the app. There were mandatory evacuations. It was crazy. All right, so
obviously that comedian is being funny about the issue, but clearly also it caused a lot of stress. And you can imagine for the tens of millions of other people that were dealing with this app and having the same stress. I mean, imagine if that was you and you had your family, you had children, you had your belongings, you had pets, you had things, and you didn't know if you needed to hurry up and leave or if you were safe or if your house was going to be burned down or what. So bad design and bad software is when products don't work the way people just naturally think that they would. AKA, bad design is when products go against users' mental models. So what's a mental model? A mental model is someone's internal representation and association of an external reality. So a mental model has a major role in cognition and decision making when it comes to many things, but especially working with digital technology interfaces. Everyone has mental models, and mental models are the internal expectations that we have about how a piece of software is going to work and what will happen if I click a button or perform some such task. Mental models are established over time, and they're based on several things, like real world physical examples. They're also based on just widely accepted existing associations, like green meaning go or successful, red meaning stop or error, and all of our previous experiences using technology. So here are a few icon examples that effectively meet people's mental models, and so they became the standard. And even as certain things have become phased out, like most of the real world examples on this slide are not used as much as they once were, like floppy disks and physical envelopes. But our association with these digital icons has become so strong that it's very likely that they'll never change, regardless of how out of date these initial references are. So, to recap this video, as I know we covered a few topics, the product development lifecycle contains many phases from planning to execution to support, plus many phases in between that talk to one another. The job roles that we cover in this course will span the entirety of that PDLC. And most companies use some kind of agile methodology to facilitate the PDLC as opposed to its inefficient predecessor, waterfall. There are many types of companies that you might work in, from B2B to B2C, from startup to enterprise, and that there are ample reasons to consider working in technology, including the flexibility to work in a variety of industries and have your own schedule, to job security, but really the ability to make a difference in people's lives is my favorite one. Thank you for watching, and please be sure to check out the other required materials before taking this week's quiz. Thanks. Bye.